In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth.
As a human being, flying in space around this incredible planet, you fall in love with it, and you realize, with a very thin iridescent blue band, which is the atmosphere that goes all the way around the planet, that's all that keeps us alive.
The threat is low, but the result can be extremely high. And we are now, for the first time in our history, at a level of technological capability to maybe detect and do something about the threat from asteroids. It's part of the legacy of this big brain and the level of quality of life that we built all around the world.
As far as we can tell, the ancient dinosaurs did not have a space program, and it cost them. They all went extinct. We don't want to go that way. An asteroid or a comet is a real and important threat.
Asteroids are just rocks orbiting the sun. Okay, this is actually every single known asteroid in the solar system, which is not all of them, but every single known asteroid accurately displayed.
We know basically more than 90% of the objects which are larger than 1 kilometer in size. And this is the threshold for global effect on Earth. Problem is now we only know 15–20% of objects which are larger than a few hundred meters in size. And these bodies, if they impact Earth, they can make like regional damages, country or even a continent.
The thing is, there are an awful lot of smaller ones which could do a hell of a lot of damage. This class of asteroid are really not charted well enough. We came to the conclusion that we needed about 100 times more vigilance to find every one of these possible impactors.
Asteroid Day has this declaration that we would like to see the rate of asteroids discovery increase by a factor of 100. That's what I would like to see. I think discovering asteroids, that's the critical step. You can't deflect something that you haven't discovered. So in a way, it's like looking both ways before you cross the street. Finding the cars, seeing the cars doesn't keep them from hitting you, but you can take evasive action. In the case of looking both ways before you cross the street, if you see a car coming, you stop. If you see an asteroid coming, well, you deflect the asteroid, but you have to see it. In a way, it's just common sense.
And the really good news is that if we look a few decades ahead, it should be possible not only to predict a possible impact, but also to do something to reduce its impact by deflecting the asteroid. What we need to have is a survey of the sky which is sensitive enough and complete enough to discover all the Earth-crossing bodies down to a size of, say, 50 meters.
One of the things about asteroids is it's a threat that we can really quantify because we can count them.
Most of the asteroid searches, interestingly, are done in the northern hemisphere, not in the southern hemisphere. And we need to have more searches in the southern hemisphere.
There's interest in South Africa of becoming a place where near-Earth asteroids could be detected, and geographically we would be a very good complement to other detection sites such as the southwestern US and Hawaii.
Actually, most of them now are detected by the Pan-STARRS telescopes and the Catalina Sky Survey in Arizona, which dominate the discoveries.
Catalina, we focus on the discovery and follow-up of near-Earth asteroids, and it's a really interesting place to be because that's where the whole process starts. You can't characterize or understand the impact risk of an object that you haven't found.
We need to have one or more space-based infrared telescopes. And today, while there are a couple of them that have been proposed, none of them has been funded yet.
With a space-based telescope, you can see in a lot more directions. You don't have a daytime sky to contend with. And two, with an infrared telescope, asteroids are much brighter than they are in reflected visible light.
There are actually a lot of things out there in space which could affect us very deeply and could wipe us out. Most of them are really not predictable and not avoidable, like a gamma ray burst. We don't understand those well enough to know yet whether we could fall a prey to something like that close by. A supernova certainly give us severe problems, but you cannot predict any of that stuff. We think that strike by something very local, which is in our own little patch, our own little solar system, it could wipe us out or it could cause us severe damage, and probably with our present state of knowledge, it is detectable and it is avoidable. So let's think about the serenity prayer for a moment. You know, you do these things which you can do. The things you can't do, you have to put off for another day. We can do this. We can look at this threat and we can probably minimize it and maybe avoid it.